Okay, Bismillah. Welcome, Mariam, to our chemistry session. Now we are going to answer question on lesson 2 about acids, salts, and bases. Okay, question number 1. Okay, Mariam, go.
Tri-basic.
Tri-basic phosphoric H3 tri-basic because it has 3 hydrogen atoms. Okay. Number 2.
Number 2, it will be 5.5.
Right, 5.5 because more than 7 will be base, less than 7 will be acid, 7 equal becomes neutral as water. Okay, number 3,
Number 3, it's a conjugate base.
conjugate base. Okay, because ammonium, whenever act with hydrochloric acid, ammonium ions NH4 is what is conjugate base. Okay, number
Yes.
4.
Number 4 is nitric acid.
Number 4 is a strong acid, right? Nitric acid. Okay. Number 5.
In the base, it will be number 9.
Number what?
It will be number D.
Number D. Yes, the color of phenolphthalein changes to fuchsia in solution of number D9. K means base. Okay. Right scientific term number 1.
Number 1 will be acids.
Acids because it has hydrogen. Okay. Number 2.
Number 2, it's an indicator.
Yes, chemical substance whose color change by the change of solution. Indicator. Okay. Number 3.
Number 3, it's a pH.
Number 3. Method for determining pH. Okay. Number 4.
Number 4 is a Bronsted Lowry base.
Bronsted Lowry base. It's okay. Base. Number 5.
Bronsted Lowry acids.
Gives away acid. Okay. Excellent, Marie. Okay. Compare between the definition of acids and bases in Arrhenius, Bronsted, Lowry, Lewis, according to giving example only and chemical reactions. Okay.
Okay, wait.
Okay.
I can't find the paper that I wrote it in.
Okay.
So
Take your time. Take your time, Maria.
Okay. Sorry, I can't find it. Can I just send it to you as PDF?
Okay, Mari. Okay, no, it's no problem.
Thanks.
Send it to my WhatsApp now or later.
Okay.
Now or later. Mariam.
Can you say again? I didn't hear.
Can you send it? Can you send it now or later?
After the session, so I can send it.
Okay, later means later. Okay, no problem. Question number 2.
Okay.
Determine the basic cations and the acidic anions of the following salts. Potassium nitrate.
Okay.
What is the symbol of potassium nitrate?
And potassium nitrate, KNO3.
KNO3. So acidic anion will be what?
The acidic anion is NO3 negative.
Right. And basic cation?
Potassium,
Right. Okay. Sodium acetate?
CH3, COONA.
Right. Acidic anion?
Acidic anion, it will be CH3, COO negative.
Right. And basic cation?
Sodium,
Sodium, Na. Right. Okay. Ammonium phosphate?
NH4,
Mm,
PO4.
okay. Only?
There is a three like bracket NH4, then another bracket 3PO4.
3, right. Because a phosphate group has a trivalent. Okay. So
Yes.
what about its acidic anion?
The acidic anion in it will be the phosphate,
Phosphate,
PO4.
PO4, okay, and basic,
It will be NH4, the
right,
ammonium.
okay, right. Copper sulfate,
The copper sulfate, CuSO4.
CuSO4. What's about anion and cation?
The acidic anion of it, it will be SO4. It's by the negative, and the basic cation is the copper.
Right, right. Okay, Mariam, right. Okay, Mariam, before, okay, so I think we finished 3 chapters, right?
Yes.
Okay, so will be homework, okay, in these 3 chapters, okay, that we are going to see it last in next session, inshallah. General test on chapter 3.
Inshallah.
Okay, Mariam?
Eh, Inshallah.
Okay. So now we are going to begin a new chapter, chapter 4, which is called the
Mister, but there is
thermochemistry.
a problem.
What's your problem?
The voice. I can't hear you clearly. It's so low.
So I think that it's from your internet because my voice is clear and I
No,
said
no, it's not
I'm sitting.
disturbed. The volume of it is so low. I tried. For me, the voice is great.
It's okay. Try to get out then enter again, Mariam. Okay.
Okay.
Okay. Wait you. Yeah, Mariam. What about the voice now?
It's better.
I think. Okay, Mariam. Now we are going to begin a new part in chemistry, chapter 4, which is called the thermochemistry. Okay, and thermochemistry represents a chemical reaction, okay, according to their absorbing or releasing amount of heat. Absorbing or releasing amount of heat. So can be called as thermochemistry. As what? As thermochemistry. Okay, Mariam?
Okay.
So what's meant by thermochemistry? What's meant by thermochemistry and thermochemical equation and so on? Okay, I think that thermochemistry, they are chemical reactions that depend on heat. Depend on heat, either losing or gaining heat. So I think we have 2 types of chemical reaction. reactions that produce heat, and also reaction that need heat. Okay, so lesson number 1, heat content. What's meant by heat content? Thermochemistry first. Thermochemistry, one of the branches of thermodynamics, which studies thermal changes which associate with chemical and physical transformation. It's thermochemistry. So what's meant by thermochemistry, Mariam?
One of the branches of thermodynamics, which studies thermal changes which associate with chemical and physical transformation.
Right. What about the law of conservation of energy? Law of conservation of energy, as we studied and we explained it before, okay, that energy can be neither created nor destroyed, but can change from one form to another. It's the law of conservation of energy. So what's meant by law of conservation of energy?
Energy can be neither created or destroyed, but can change from one form to another.
To another, right. It's the meaning of what?
Law of conservation of energy.
Right. Law of conservation of energy. Okay. So after this law, uh, we are going to talk about chemical reaction. Chemical reaction, okay, are associated with changes in energy. They may absorb or give off energy. Energy is exchanged. Energy is exchanged between the medium of the reaction called system. So medium of reaction called system, and the surrounding medium called surrounding. So we have two types. Okay, we have two types according energy. Energy can be exchanged between the medium of reaction and surrounding. Medium of reaction called what?
System.
System. While the surrounding medium called what?
Surrounding.
Surrounding, right. So what's meant by system? System, a of the universe, part of universe in which chemical or physical changes occur, or the certain part of matter which is studied. This is a system. System, K means medium, that energy, that chemical reaction or energy can be exchanged. Okay, it's called system. So it's a part of the universe in which chemical or physical changes occur, or the certain part of matter which is studied. So what's meant by system?
A part of the universe in which the chemical or physical changes occur, or the certain part of matter which is studied.
Right. And what's meant by surrounding? Surrounding is the region surrounding the system, region surrounding the system, which exchanges energy with it in the form of heat or work. Heat or work. So what's meant by surrounding?
The region surrounding the system which exchanges energy with it in the form of heat.
Yes. Mariam?
I said it. I will say it
Oh,
again.
okay, I know.
Surrounding.
It's okay. It's surrounding. So surrounding surrounding the region surrounding the system, which exchanges energy with it in the form of heat or work. Okay. After that, as system and surrounding chemical reaction. So system means what? Means a medium in which chemical or physical change can be exchanged as beakers, flasks, or test tubes in which chemical reaction occurs, right? While surrounding anything around the medium of the chemical reaction. Anything around the medium of chemical reaction. Okay, Mariam? So
Okay.
what about the examples of systems and surrounding as what, Mariam?
As beakers, flasks, or test tubes in which the chemical reactions occur. This is the system. The surroundings, that anything around the medium of the chemical reactions.
Okay, around the chemical reaction. Okay. So what about the types of system? What about the types of system? Okay.
Okay.
Number one, isolated system. Number one, isolated system. What's meant by isolated? Isolated as water in isolated container. Water in isolated container. Okay. So it doesn't allow the exchange of matter or energy between system and surround. As if you make tea, then put it inside its boiler, okay, then cover it, okay. So the hot tea became or becomes hot, okay, becomes hot without losing any energy if you opened it to pour some of tea. Rather than this way, it will save its temperature. So isolated system, it allow doesn't allow the exchange of matter or energy between the system and surrounding. Example, water in an isolated container. Okay, Mariam?
Okay.
So what's meant by isolated system?
It doesn't allow the exchange of matter or energy between the system and surrounding. Example, water in an isolated container.
Yeah, it's called isolated what? Isolated system. It's called what? Isolated system. Okay? Okay.
Okay.
Uh, can you give me another example about isolated system?
Food in a pot.
Food in a pot, right, right. But this pot must be made to not lose or gain any energy. So it's called isolated.
Yes.
Yes, so it's called what? It's called isolated system. Okay,
Yes.
okay, right. After this example, uh, another one as open system. Open system, it allows the exchange of both energy and matter between the system and surrounding, as water in an open sea. Okay, if you poured some some of tea in cup and this cup exposed to air, what happens for this open system? It allows transformation of heat, okay, between cup of tea and surrounding, right, and air. So it will lose its energy. So it's called open system. Open system, it allows the exchange of both energy and matter between the system and surrounding, as water in an open sea. Okay, Mariam, try to repeat it again. What's meant by open system?
Open system, it allows the exchange of both energy and matter between the system and surrounding. Example, water in an open sea.
Water in open sea. Okay. A closed system is a third example. It allows the exchange of energy only, not matter. Exchange of energy only between the system and surrounding in the form of heat or work as thermometer. If you put thermometer, okay, hot in a hot cup of tea, what happens? I think energy will transfer to thermometer only, okay, not to the other, not to surrounding. If you are hot, okay, suffer from cold, okay. I think that when your mom try to measure your temperature, okay, so she will put the thermometer in your mouth as example. So the energy will transfer from your body to thermometer, not to hand of your mom, right?
Right.
So it's called what?
Closed system.
Right, it's called the closed system, that it allows the exchange of energy only between the system and surrounding in the form of heat or work, as a thermometer. So what's meant by closed system?
Closed system, it allows the exchange of energy only between the system and surrounding in the form of heat or work. Example, thermometer.
Thermometer, right, Marie. So number one, first law of thermodynamics. What about the first law of thermodynamics? First law of thermodynamics means that the total energy of isolated systems remains constant, even if the form of system changes. Even what? Even the form of system changes. So what's meant by first law of thermodynamics?
First law of thermodynamics, the total energy of isolated systems remains constant even if the form of the system changes.
Right. Its explanation. We know that the universe equal what? Universe. Universe includes system and surrounding, right?
Right,
So the change of the universe energy equal change of the system energy plus change of the surrounding energy, right?
right,
By simple, so delta E universe, okay, energy of the universe change, delta E means change in the universe energy equal change in the system energy, delta E system, plus delta E surrounding, change in surrounding energy. So therefore, any change occurs to the energy of the system is associated with an equivalent change in that of surrounding, but with different sign to keep total energy. As there are, as example, energy absorbed and energy released. So they will be in a negative sign or an opposite sign. Okay, because delta E system equal delta E equal negative delta E surrounding. Okay, Mariam, because they can be lose or gain of energy between both system and surrounding. So it will be by negative as losing energy, okay, will meet by gaining energy. Okay, Mariam?
okay,
So therefore, any change occurs to the energy of the system is associated with an equivalent change in the surrounding, but with different sign, okay. As when you if you try to make any chemical reaction. Okay, but this chemical reaction needs heat. Okay, as example, burning magnesium strip. By burning magnesium strip, so you will get this magnesium and you will burn it. Okay, so it will produce energy, right? The energy absorbed by magnesium strip will meet by energy produced from this reaction as eliminus of this magnesium after burning. Do you understand, Mariam?
Yes.
So delta E system equal negative delta E surrounding, right?
Right.
What about heat and temperature? Okay, try to listen to this part, Mariam, please.
Heat. When a gummy bear is dropped into heated potassium chlorate, a chemical reaction takes place. This reaction can be described by the overall equation. C 12 hours 22O11 plus 8 KClO3 right arrow 12 CO2 plus 11 hours 2O plus 8 KCl.
So it's a reaction of gummy beer is dropped into heated potassium chlorate. Potassium chlorate. What happens to this? Okay, listen.
There's also another product, energy in the form of a good deal of heat and some light. In thermochemistry, you will study the heat released and absorbed by chemical processes.
So it's what you are going to study in thermochemistry. Study the heat released and absorbed chemical processes. Okay, try to observe this video, Mariam. So what happens? What's your observation, Mariam?
It released light.
Light only?
Light and energy with smoke.
Yes, and heat energy from system to surrounding, right?
Right.
So it's called opened or closed or isolated system.
Closed.
Called what? Called opened.
Closed.
Called what?
Opened.
Called opened, right. So it's about thermochemistry. It's specific heat. Okay, not now. Specific heat. Chemical energy and the universe. It's the definition of thermochemistry. What's meant by thermochemistry, Mariam?
The study of heat changes that occupy chemical reactions and phase changes.
That accompany chemical reaction, not occupy.
Okay.
So the study of heat changes that accompany chemical reaction and phase changes. Okay, it's the meaning of thermochemistry. And this is the system. What's meant by system?
And in thermochemistry, the specific part of the universe containing the reaction or process being studied.
Yes, the reaction or process being studied. It's the meaning of system. What's meant by surrounding?
And thermochemistry includes everything in the universe except the system.
Yeah, except system. Everything in the universe but except system. What about the universe?
In thermochemistry is the system plus the surrounding.
System plus surrounding, right. Okay. What's your opinion, Mariam, in these studied parts? What's your opinion?
My opinion from which
From this part,
kinds of
from this book then can explain that I explains from it. What's your opinion?
it's of course better than the book that I study from.
It's okay. Thanks, Murray. So this video about an endothermic reaction. Endothermic reaction between barium hydroxide and ammonium chloride. What's meant by endothermic? There are two types of chemical reaction, which are both endothermic and exothermic. What's the difference between them? Can you imagine? Can you imagine, Mariam, what's meant by endothermic and exothermic? It's from its name, endo, and the other exo. Okay, imagine what's definition between endo and the exothermic reaction.
That that I start by the exothermic reaction.
As you like.
No, wait. The exothermic reaction.
Yes.
We took the solutions.
Which what?
We took the exothermic solutions and the endothermic solutions.
No, endothermic reaction, not solution. Reaction.
Reaction?
Yes.
Maybe the exothermic reaction, it gives away the heat, while the endothermic, it absorbs it.
Right. Excellent, Mariam. Excellent. Exothermic, they are the reaction. Exothermic, they are reaction, okay, that release energy. Okay, so it's called exothermic reaction. While endothermic reaction, okay, it's energy, endothermic reaction that need amount of energy. So it's difference between them. Need amount of energy. Okay. So it's difference between both endo and exothermic of reaction. Right?
Right.
Okay. So what about this? Watch this video about endothermic reaction.
Okay.
Again. What about this degree will decrease or increase?
It decreased.
It will decrease or increase?
It was 18, then it became 17, then 16. I think it will decrease.
But by negative sign, not positive.
I didn't see the negative sign.
Negative 19, okay?
Okay.
So it will be negative 18, negative 17, negative 16. So
Negative
by
16.
putting this device in the reaction, okay, it will absorb energy.
It will
Okay,
increase.
absorb energy. But by cutting off this device from the reaction, the temperature will increase from negative 19 to negative 16, right?
Right.
So it's called what? It's called endothermic reaction. Called what?
Endothermic reaction.
Endothermic reaction. Okay, Mariam?
Okay.
Any problem till now?
No.
It's okay. الله أكبر الله أشهد أن لا إله إلا الله أشهد أن لا إله إلا الله أشهد أن محمد رسول الله أشهد أن محمد رسول الله لا حول ولا قوة Let's complete. What's meant by temperature? Try to read, Mariam.
The measurement of the average kinetic energy of the molecules of substance, which determines if it's hot or cold.
So temperature, the measurement of the average kinetic energy of the molecules of substance, which determines if it's hot or cold. What's meant by system?
The group of molecules which react with each other when the average kinetic energy of the molecule of a substance increase, the temperature increase. I don't
Yeah.
understand.
What?
I don't understand the idea of the system here.
System. The system group of molecules. Group of molecules which react with each other, as if you made a reaction between magnesium and oxygen. Okay, so the system includes molecules of magnesium and molecules of oxygen that react with each other, forming the product, right? So system
Right?
means the group of molecules which react with each other as the reactants of chemical reaction. System means reactant of chemical reaction. When the average kinetic energy of the molecules of substance increase according to this reaction. So in kinetic energy of molecules will increase and temperature also will increase. So it's meaning of system. Have you understand?
Okay. Yes.
Okay. What's meant by heat?
A form of energy which is transferred between two objects of different temperatures.
So heat, a form of energy which is transferred between two objects of different temperature. So heat will transfer from higher object to lower or opposite.
From higher opposite to lower.
So what happens if you touch a hot cup of tea?
My hands will burn. If it's too
Why?
hot, it will be transferred to
Because
me
heat
to the heat
transfers from what to what?
from the hot cup of tea to my hand.
So what happens if you touch a piece of ice?
It will be cold on my hands.
So in this case or in this situation, heat will transfer from what to what?
It's according to if the object is hot or cold. If it's cold, then the high and the coldness
I said I mean this situation. I mean this
in this
situation.
situation,
This situation,
it will
okay,
be
is that
from the
when
lower.
you touch a piece of ice, you said that you will feel cold, right?
Yes,
So heat will transfer from what to what?
from the lower temperature to the higher one.
How? But we said before that heat always transfer from higher object to lower object.
I understand it, but I don't know what to say.
So heat must transfer. Heat must transfer from higher temperature object to lower temperature object. So when you touch a piece of ice, I think that your hand will be higher temperature object, right?
Yes,
So you will feel coldness as transferring of heat from your hand to piece of ice, not from piece of
and
ice
ice will
to your
melt.
hand.
I understand.
Okay, do you understand?
Yes,
Yes, so heat, you feel coldness because heat transfers from higher temperature object, which is your hand, to lower temperature one, which is a piece of ice. After that, the energy of a system is directly proportional to the kinetic energy of its particles. Okay, as when kinetic energy increases, so the energy will increase, and vice versa. By decreasing kinetic energy, so the energy will be decreased, right?
Right.
What about the measuring units of heat? We have as example calorie. Calorie, and its symbol is CAL, calorie. What's calorie and joule? What's meant by calorie?
The amount of heat required to raise the temperature of 1 gram of water, 1 Celsius.
1 Celsius, okay. So what's meant by joule?
The amount of heat required to raise the temperature of 1 gram of water, 1 over 4.184 Celsius.
Yeah, okay. So it's a difference between them. Difference between them. Okay, as joule equal 4.18 calorie, and calorie equal 1 over 4.18 joule. Okay, so it's a relation between them. What's the relation between them again?
That the 1 joule equals 4.184 calories, and the calorie equals 1 over 4.184 joule.
84 joule, right. So it's the relation between both of them. Okay, relation between both of them. Okay, so
Okay.
it's very important, calorie and joule. Calorie, amount of heat required to raise temperature of 1 gram of water, 1 Celsius. So it's called the calorie. Okay, but joule, the amount of heat required to raise the temperature of 1 gram of water, 1 over 4.18 Celsius. So 1 joule equal 4.18 calorie, and calorie equal 1 over 4.18 joule. Specific heat. What's meant by specific heat? Specific heat means the amount of heat required to raise temperature of 1 gram of matter, 1 Celsius. It's called specific heat, and it's specialist. Okay, it's specialist or specialized for each substance. So specific heat, the amount of heat required to raise temperature of 1 gram of this matter, 1 Celsius, and its measuring unit equal joule per gram. Joule per gram Celsius or joule per gram Kelvin. Because specific heat can be measured by Celsius or Kelvin, and both units are measuring units of temperature, Celsius and Kelvin. So what's meant by specific heat?
The amount of heat required to raise the temperature of 1 gram of matter, 1 Celsius.
Right. What its measuring unit?
Joule per gram Celsius or joule per gram Kelvin.
Right. So specific heat depends on the kind of substance, as the specific heat is high in substance which require great amount of heat to raise their temperature, and they take much time to lose heat, heat, because they require great amount of energy. And in the opposite to substance which with low specific heat. Okay, as water. Water has the greatest specific heat on the surface on the earth. Okay, specific heat to raise temperature 1 gram, 1 Celsius. So this example about substance that differ in their specific heat. Aluminum, as example, 0.9. Carbon, 0.7. Copper, 0.38. Iron, 0.4. Liquid water, 4.18. Okay. Water vapor, 2.01. Okay. Liquid water, 4.18. Okay. Do you remember this number, Mariam? 4.18?
4.18.
Right. We explained it before for a while. 4.18 the joule. The amount of heat required to raise temperature of 1 gram of water 1 over 4.18. We said that 1 joule equal 4.18 calorie, right? It's 1 joule. So 4.18 means 1 joule. Okay, Mariam?
Like here, the H2O
Yes.
equals the joule? Equal 1
Yes.
joule?
Yes, but in liquid state. Okay, in liquid state.
Because in the gas state, it will be 2.01.
Yeah. 2.01. Okay.
Okay.
How can we calculate heat amount law? Specific heat amount. Q equal M times C times delta T. This problem is very important to calculate specific heat. Q, the amount of heat at certain pressure. Q, amount of heat. M means mass of substance. C is specific heat. Delta T is difference between final temperature, T2, temperature after heating, and initial temperature, T1, temperature before heating. So delta T must equal T2 minus T1. Final temperature minus initial temperature. And there is another rule which is called heat capacity. Heat capacity, C capital, equal MC. Equal MC, mass times specific heat. Mass times specific heat. And the amount of heat is measured by a device called the calorimeter. Calorimeter. So the amount of heat is measured by a device called the calorimeter. Called what?
Calorimeter.
So how can we calculate heat amount law? Q equal what?
Q equal MC delta T.
Okay. Q represents what?
Amount of heat at certain pressure.
M.
The mass.
C.
Specific heat.
Delta T.
The difference between T2, which is the temperature after heating, and T1, which is the temperature before heating.
Okay, wait, Mariam. Okay, Mariam, so it's called the calorimeter. And we said before that amount of heat is measured by device called the calorimeter, okay? What is the function? What is the function?
Wait for 1 minute.
Yes,
I will do
yes.
something. I will do something because a problem happened, I think.
It's okay, okay, take your time. Take your time, Mariam.
I'm back. Sorry for the pause, but just I needed to do something so fast.
Okay, Mariam. Thanks, Mariam. Okay, welcome back, Mariam. So what's meant by what's the function of calorimeter? Try to read, Mariam, please. What's meant by function of calorimeter?
It measures the heat of chemical reaction of physical changes.
Yeah, it measures the heat of chemical reaction of physical change, and it provides us with an isolated system whose temperature can be calculated, and it doesn't allow the exchange of energy and matter between the system and surrounding. So this enabled us to use a certain amount of substance with which thermal exchange occurs. And also water is used usually because it has high specific heat, as we said before, which allows it gain and lose a great amount of energy. Then we calculate the change temperature by the following law. What is the law? That we can calculate change of energy using it, okay, as delta T equal T2 minus T1. Delta T, change of temperature. T1, initial temperature, means temperature before heating, while T2, final temperature, means temperature after heating. Okay? And the component of calorie meter, okay, isolated vessel, thermometer, stirrer, and a liquid, usually water, as this structure. This is a structure of calorimeter. Okay? Okay, isolated
Okay.
vessel, isolated vessel, okay, thermometer, stirrer, liquid, and usually water. This is a structure of calorimeter. Okay, Mariam?
Okay.
Okay, so I think that it's enough. We are going to complete, inshallah, in next Thursday. Okay, Mariam?
Inshallah.
Okay, do you
Inshallah.
understand?
Yes.
Any problem till now?
No.
Okay, Mariam, I think that you have homework, okay, on chapter 3 that we are going to make a revision for it, inshallah, next Thursday. Okay, Mariam?
Inshallah. Inshallah.
Okay, inshallah, Mariam.